Welcome, my young math Padawans. This is lesson 3-2, part 2, more about complex numbers. In the last video, we took a look at adding, subtracting, and multiplying complex numbers. In this video, we're going to take a look at dividing complex numbers, as well as some of the ways we're going to use and see complex numbers come up in our problems. So first, let's talk about how to divide complex numbers. This is where it gets a little different because we can't actually divide these directly. There's no way to come in and take that 5 plus 4i and divide 7i into it evenly. It doesn't work out the way normal numbers do. So instead, what we try to do is we try to work to get the I off of the denominator of the fraction. Because remember, after all, this is the square root of a negative number, and that's no good for us. So the strategy that we're going to use to get I off the denominator is we're going to multiply by something called the conjugate. Okay? And the conjugate of a complex number, so let me start with a regular old complex number, a plus bi. The conjugate of that number is going to be a minus bi. So you'll see the only thing we're changing is the number that's in between, specifically the number or the sign of what is in front of the I term. So when I look at 5 plus 4i divided by 7i, in order to get rid of that I that's on the denominator, I'm going to multiply the top and the bottom by negative 7i. That would be the conjugate. And I have to do the same on the top as I do on the bottom because that's the only way to keep this thing equivalent, right? I'm really multiplying by 1. The same thing on the top as I do on the bottom. Okay, so on the top, that means that I'm going to have to take this negative 7i and I'm going to have to distribute it in. So let's see here. 5 times negative 7i is negative 35i. And positive 4i times negative 7i is negative 28i squared. That's the top. On the bottom, I'm going to take this negative 7i and multiply it by positive 7i. Well, we'll do numbers times numbers and get negative 49, and variables times variables, and I'll get I squared. Okay, next step. I'm going to take my I squareds because I remember from the last video that my I squareds actually turn into negative 1s. So this becomes negative 35i minus 28 times negative 1 over negative 49 times negative 1. So I changed my I squareds to negative 1s. Now I'm going to do just this last step of math. So nothing happens with the negative 35i, but the negative 28 times negative 1 becomes positive 28. And on the bottom, I got negative 49 times negative 1, which is positive 49. One more thing I'd like to do, I'm just going to rewrite this. I'm going to rewrite this as 28 over 49 minus 35 over 49 times I to get it in that complex form. And then last, I'm just going to simplify my fractions. So I know both 28 and 49 are divisible by 7. So I get 4 over 7 minus, and you know what? 35 and 49 are also divisible by 7. 5 over 7i. And that is my final answer. See, there's no way to just simplify fractions and come up with this. We would not be successful if we tried. All right, second one. 4 divided by 2 minus 3i. Again, it's not so much about division as it is multiplying by that conjugate. 2 plus 3i. Okay, so now we're just going to take this 4 and we're going to distribute. So we'll get 8 plus 4 times 3 is 12i over, okay, be careful here. Be careful on the bottom. We have to FOIL, right? So 2 times 2 gives me 4. And that's the firsts. And then the outsides would give me 6i. And the insides minus 6i. And the last minus 9i squared. Let me just extend that fraction bar a little bit more. All right, we'll keep going. Nothing to do on the top. That's just going to stay. On the denominator, well, let's see here. I'm going to have 4. The 6i and the negative 6i, those cancel out. So I really have 4 minus 9 times negative 1, which is the same as plus 9, right? So I get 8 plus 12i over 9 plus 4, which is 13. Rewrite it as a fraction. 8/13 plus 12/13 I. That's my final answer. Okay, one more example to do here. 2 plus 6i over 2 plus 3i divided by 2 plus 3i. I again am going to multiply by the conjugate of what's on the bottom, which is 2 minus 3i. Oh man, I got a lot of foiling to do here because it's all foiling all the time. So on the top, I'll do the firsts. I'll do the outsides. I'll do the insides. And I'll do the lasts. On the denominator, I'll do the firsts. I'll do the lasts. I'll do the insides. And I'll do the lasts. All right, let's combine my like terms. So on the top, I got 4. Negative 6i plus 12i is plus 6i. I got that negative 18 times I squared. That's the same as plus 18, right? Because that I squared is negative 1. Trying to shortcut just a little bit of my work here. I'll have the 4. The negative 6i and the positive 6i cancel out. Minus 9i squared. Remember, that's negative 9 times negative 1, which will give me plus 9. And one more step to simplify things. 4 plus 18 is 22. I got 22 plus 6i on the top. And on the denominator, 13. 9 plus 4 is 13. Rewrite it as a fraction. 22 thirteenths plus 6 thirteenths I. And I've simplified that. You can expect to get a lot of these fractions when you're doing and dividing complex numbers. They rarely turn out nicely. So why don't you pause the video right now and give these 3 problems a try, and then we'll go over the answers here momentarily. Okay, try to keep your math straight. Don't forget I squared is equal to negative 1. Don't forget to FOIL. Try them out, pause the video, and then we'll go over the answers soon. Okay, for this first problem, we're going to multiply by the conjugate. I'll make sure that I distribute that in. Ooh, let's do a better job. So I get positive 2i plus 10i squared over negative 4i squared. That's here. This that I squared, that top will turn into negative 10 plus 2i. Just flip-flop the order a little bit. On the bottom, that's really negative 4 times negative 1, which is positive 4. I'll split that into my 2 fractions. I'll get negative 10 fourths plus 2 fourths I. I'll simplify my fractions. I'll get negative 5 over 2 plus 1/2 I as my final answer. The next one, again, multiplying the top and the bottom by the conjugate, which is 5 minus 3i. On the top, I'm going to distribute. That'll give me 15i minus 9i squared over, foiling on the bottom. I got the firsts, 25. I got the outsides, minus 15i. I got the insides, plus 15i. I got the lasts, minus 9i squared. On the top, that really turns into 9 plus 15i. On the bottom, my negative 15, positive 15 cancel out. I really have 25 plus 9, which turns out to be 34 when I do the math. Get that top and write that top again. Now we'll just simplify the expression. 9 34ths plus 15 over 34i. There's nothing that can really be divided into those fractions, so we'll leave them the way that they are. Okay, last problem. Multiplying by the conjugate, 4 plus 2i over 4 plus 2i. That's a whole lot of foiling. Let's foil the top. I get 20. That's the first. I'll do the outsides, plus 10i. I'll do the insides, plus 12i. I'll do the last, plus 6i squared. On the bottom, I got 8. Sorry, not 8, 16. Plus 8i minus 8i minus 4i squared. Okay, on the top, let's combine our like terms. I got 20. I got the 12 plus the 10, which is 22i. And then really that turns into minus 6 at the end. On the denominator, 16. The negative and the positive 8i cancel out. Plus 4 on the bottom. All right, on the top, let's see here. That gives me 14 plus 22i over 20. I'll rewrite that as two separate fractions. And I'll simplify those fractions. Let's see here, 7, both divisible by 2. So that's 7/10 plus 11/10 I for my final answer. Okay, so that's dividing complex numbers. Now, so far we haven't seen where these actually fit and how it connects to what we were doing. Let me show you. So we're going to solve a couple quadratic equations, and I'm going to show you exactly where these complex numbers come up and how they work in these problems. They really aren't going to show up when you're solving by factoring, because if it's factorable, you're not going to have to deal with negative roots, negative square roots. But they will show up in problems where you're using the square roots, where you're solving by completing the square, or where you're using the quadratic formula. I'm going to show you one of each of those here right now. So first, problem number 1, x squared plus 4 equals 0. Well, remember, there's no x variable here. So the easiest way to solve this would be to subtract 4 from both sides. And now that we have x squared by itself, we can actually take the square root of both sides. We get x equals, we took the square root, so we need a plus or minus, and we have the square root of negative 4. Now, there's my negative underneath the radical. We know what that is. That's x equal to plus or minus 2i after I simplify that radical. What the heck does that mean? Well, if you think about the graph of x squared plus 4, okay, there's the x-axis, there's the y-axis, right? X squared plus 4 would be shifted up 4 units, and we would have a quadratic that would look like this. I know my picture's not the greatest, but you get the idea. Remember that solutions to quadratic equations are where it crosses the x-axis. This graph does not cross the x-axis. It's all the way up here. So it has no solutions. But we still need to account for it by doing some algebra. So even though it doesn't cross the x-axis, that really means that there are no real solutions. Instead, we have 2 imaginary solutions. Every quadratic equation will have 2 answers. Sometimes they're real, sometimes they're imaginary. We have to find them. And by doing this process, we will solve for all of the solutions to the quadratic equation. Let's take a look at another example. I told you I would use all the methods. So in this problem, I'm going to solve by completing the square. But before I do that, I have to get rid of this 3 that's in front of the x squared. It'll make my life easier. So I'll divide everything by 3, and I'll change the problem. It will become x squared plus 4x plus 5 equals 0. I'm going to move my 5 to the other side. That will leave space for the box to figure out what I'm going to add to both sides. And again, remember, I'm going to do that 4 divided by 2. 4 divided by 2 is 2. So I'm going to add 2 squared to both sides. 2 squared is 4. I'll simplify that over on the other side. On the left, this becomes x plus 2, that quantity squared, equals. And on the right, negative 5 plus 4, which is negative 1. I will now take the square root of both sides. That'll give me x plus 2 equals plus or minus the square root of negative 1, which we know to be I. So I have x plus 2 equals plus or minus I. We'll now subtract 2 from both sides, and I will get negative 2 plus or minus I. Now remember, that's 2 solutions, right? That's negative 2 plus I, and that's negative 2 minus I. There's my 2 answers for this particular quadratic equation. Okay, we got one more to do. And for this one, I'm going to use that last method, our failsafe, the quadratic formula. So I'll identify A, I'll identify B, I will identify C, and then I'll fill in the quadratic formula. X is equal to the opposite of B, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. All right, so that's negative 2 plus or minus. That'll be 4 minus 20 all over 10. Keep going. Negative 2 plus or minus the square root of negative 16 over 10. Hey, there's my I. I'm going to go up here for some more room. So that'll give me x equals negative 2 plus or minus the square root of negative 16 is 4i all over 10. I should simplify this fraction a little bit. So I will get negative 1 plus or minus 2I over 5. Again, that's my two answers. That's my two answers, negative 1 plus 2I over 5 and negative 1 minus 2I over 5 for the final solution to this quadratic equation. Okay, we've seen a couple different methods. I don't care what method you pick here, it's up to you. I would probably try to complete the square with number 4 and definitely use the quadratic formula for number 5, but that's my opinion. If you want to use the quadratic formula for both of them, that's fine with me too. But pause the video right now and give these two problems a try. See what you come up with. We'll go over them here momentarily. Okay, for this first problem, again, I'm going to move that 5 over to the other side. And then I'm going to complete the square. That'll be adding 1 to both sides. That'll turn this left side into x plus 1 squared equals negative 4. I'll take the square root of both sides. I'll get x plus 1 equals plus or minus 2I, and I'll come up with my final answer, negative 1 plus or minus 2I. For number 5, I'm going to use the quadratic formula. So the first thing I need to do is set it equal to 0 so that I can identify a, b, and c. And now I'll fill it in. X is equal to the opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2a. Oops, I did the math ahead of time, 2 times 4. All right, and now we'll simplify this down. And I'll keep going with the next step. I'll simplify my radical. And I'll now simplify my fraction, which gives me my final solution here. All right, folks, we will definitely be practicing this in class. So if you have any questions, please keep them for me, and I'll be happy to answer them when I see you next. Good luck, and thanks for watching.